Welcome to this video. I think this is the fourth video in a series. It's about describing, explaining performance measurement metrics for tracking applications such as aeroplane tracking using radar measurements, tracking estimations, and truth target data as well. I think depends. Yeah, I think first video was defining the scenario. Second video was performance categories, sensor measurement related or track estimation related. And also we define like algorithm free for the tracker dependent, algorithm free, algorithm dependent. We define those. And also for algorithm free, we define some cardinality. Algorithm free performance measurements based on cardinality, time measurements, and available truths. Yeah, I think we will extend on more on the algorithm free measurements. Yeah, it's not algorithm dependent. It just generalized performance metrics for tracking application. Yeah, available truths was the last thing that we discussed. Now unavailable truths. Say, in this case, I think it's tracker dependent. We have the sensor measurements, but we don't have the truths. In absence of the truths, how do we measure that our tracking performance? I think it will be just consistency of estimations, the tracking that we are assigning, whether they are consistent or not. We have to find out the innovation of estimation from the sensor measurements. I think innovation, the norm of difference. Yeah, that's innovation. Yeah, how consistently we are doing it over the time for different tracks and those kind of things using the, because we don't have the tools available. Anyway, so algorithm free track cardinality measures. Yeah, I described it to some extent on the third video. Yeah, on the third video, I will do one more time, a little bit more information, I believe. Track cardinality measures. Okay, it's tracker dependent performance measure. It's algorithm free, and it depends on the cardinality measures. It's not time measures. It's not time measures, right? Anyway, so we have the track result and we have the truth data. So valid tracks. Valid tracks, count of valid tracks is a measure. And what is a valid track? A target is assigned to one target. The target is not assigned to any other. So we have assigning one target to one track, and we are not assigning the same target to another track. So count of valid tracks or ratio of valid tracks, those kind of measures can work. And the track, yeah, should be good estimation of the track's original target trajectory. Missed tracks. So missed tracks, yeah, count of missed tracks or ratio of missed tracks, those kind of things. But what is a missed track? Missed track, if we missed a target, we could not find the estimate that trajectory tracks for that for a target. That's the missed track. I think if a target is not assigned to any tracks, yeah, count of missed tracks, ratio of missed tracks, those can be the measures. False tracks. False tracks, I think we found a track, but there is no target. There is no real target following the track. So that's a false track. No target is assigned to the track. No target is assigned to the track, only false alarms, for example. Spurious tracks. I think you are telling, okay, this is a one track for one single target, but that actually have taken mixed up two different valid targets tracks. Completeness, number of valid tracks per truths. Okay, I think let's see. Yeah, two true target and two valid track truth. Now, we have calculated 4 valid tracks. So 4 divided by 2 per truth, there are 2. So yeah, it's not complete, right? It's incomplete. It's not, I think, it's not a, yeah, your algorithm is not working well. Swaps in tracks, track crossings by targets. Yeah, I think 2 targets overlapping each other. So they are swapping. Yeah, you might alter the one track for another target. I think you just do some mess up. I think watch the third video. It will have more detail there. So the measurement is count of track segments for each target over the total time. Broken tracks. Yeah, you missed the tracks for some times. I think you're tracking it and you could not track it, but you again come back to the tracks. So there are some broken. So for each time step, there is no track assigned to the track. I think if you want to actually calculate the measures, so it is, I think, for each time step. So how many of the tracks are not assigned to the truth? Then count of there is no track assigned to the truth. So count, yeah, count of broken tracks. That's what it is. Okay, I think in the next video, I will describe the time measurements that are used for the algorithm-free tracking performance. Yeah, algorithm-free tracking performance. I think in this video it was mostly algorithm-free based on the cardinality measures. So next will be algorithm-free time measures for the performance of tracking applications or tracking algorithms. It's algorithm-free, right? Generalized. Anyway.